كمان we're going to continue. Most of these are revision from last year. Derivative using chain rule. We know from composite function dy over dx is y prime of u times u prime of x. Y prime of u times u prime of x. So if you have f of x equal x power n, this is not of the form u power n, this is x power n. So derivative, you know, it's n, x n minus 1. But if it is u, if you have u, we're going to add to it what like we did in composite, u prime. Because in composite we said it's f prime of u times u prime. So always if you have expression of x, you add u prime. So if you have it u power n, you took it last year, it's n u prime u n minus 1. Radical x, it will be 1 over 2 radical x. But if you have an expression, it will be u prime over 2 radical u. Sin u, sin x, it was cosine x. Now because you have expression inside of x, okay? So like here, it's not sin x, it's sin 3x squared minus 2. So it's u prime cosine u. You always add what? U prime. Tangent u prime over cosine square u. Cotangent u minus u prime over sine square u. Cosine u minus u prime sine u. So find this derivative. This is of the form u power n. Derivative is n, you need 2 into 3, and u prime u n minus 1. So 2 into 3, you derive inside, which is 2x minus 3, and 2, you decrease the power by 1. This is of the form u times v. So it's u prime v plus v prime u. I'm going to do it step by step. Now it's of the form u power n. So it's 3 into derivative of 2x squared minus 5, 4x into 2x squared minus 5 power 2 into cosine x. Derivative of cosine x is minus sine x. Here it's not of the form chain rule. It's cosine x directly minus sine x. Here this one, it's of the, this is the first one, sine u. Derivative of sine u is u prime cosine u. So you derive inside. So it's 6x cosine 3x squared minus 2. And derivative of minus 2x is minus 2. This is of the form radical u prime over 2 radical u. You derive inside. This is 4x minus 5 over 2 radical u. This is u over v. I'm going to do step by step. U prime v minus v prime u. Here very easy to do it. So it's minus 6x. Minus 6x into minus 2 into 2 sine 3x minus 2 over square. Now this is of the form sine u. It's u prime cosine u. Derivative of 3x is a 3. Cosine 3x minus 2. You know this. This is of the form cosine x all power 3 power prime. This is of the form u power n. So it's n, which is a 3. U prime derivative of cosine x is minus sine x, and you decrease the power by 1. Here it's the same. It's of the form u power n. And you have sine 2x squared minus 3x minus 1 power prime, all power 4 prime. So it's of the form u power n. You put the 4, then the derivative of this one, as you can see here, I have a prime. Then I decrease the power. Instead of 4, I put it as 3. Now this is of the form sine u prime cosine u. So 4x minus 3 into cosine 2x squared minus 3x minus 1. One of the things you took last year, it was point of inflection, where you switch where you switch from the positive concavity towards negative concavity. So here it was negative, then positive. Or if you have like this, and then you have this switch, this is point of inflection. You took it last year. So here second derivative, to find the point of inflection, second derivative equal to 0. If it's positive, it means concave up. If it's negative, second derivative concave down. So to prove that we have a minimum, like here, first derivative must be 0. F prime of a, as we said, to have a minimum must be equal to 0. But the second derivative at that point a, to have a minimum, must be positive. And to have a maximum, so first derivative must be 0, but the second derivative, to have a maximum, it must concave down. So f prime of x must be less than 0. You took this last year. So find the point of inflection here. It's 4x cubed minus 3x squared minus 6x minus 4. Then I do this. I want to check if also if the max and min that I have is maximum or minimum without graphing. So here, if I put it in the calculator, I'm going to get a root 1.85. Well, 1.85 is either a max, because derivative equal to 0, or min. So to know if it's a max or minimum, I do the second derivative. I do f double prime of 1.85. Since it's positive, what does it mean? It concave down and it's at the same time derivative equal to 0, so this is a minimum. And to find the inflection point, I equate second derivative as I did here to 0. I have x is 1 and x is minus half. I have two inflection point. The first inflection point here is 1. You replace to get f of 1. And the second inflection point, I prime, is minus half and f prime and f of minus half. Inverse function, we took it last year. So if you have f from x to y, if you want to return back, this return back is called f inverse of y. You have x, you go to y, y equal f of x. If you want to return back, you have f inverse of y. Always when you have to have an inverse function, the function must be monotonic. It's either, it's a bijection, always increasing or always decreasing. So when it's increasing or decreasing, we can talk about inverse function. If not, we cannot talk about inverse function. But if x here is the domain, y will be the range. In inverse function, y will be the domain and x will be the range. So that's why, and always function, for example, if you take this blue curve, f of x, if you want to find the inverse, you draw y equal to x, and you draw the symmetry with respect to y equal to x to graph the inverse function. You took it last year. So steps to follow to find inverse function as you did before. You check if it's 1-to-1 and onto. It's always from the table of variation. Most of the time when graphing, you check if it's increasing or strictly decreasing. You say the inverse is a function. If not, you say the inverse is not a function. You don't do it. We replace x by y and y by x, and you solve for y. Let us take examples here. Here, you know, f inverse rho f of x is x, and f rho f inverse of y is y, because if you go to x, and if it's monotonic to y, and then if you want to return back, you're going to get x. Find f inverse, then indicate its domain when required. You have y equal f of x equal minus 3x minus 5. أول شيء f of x equal minus 3. It's strictly decreasing, so inverse is a function. You replace x by y and y by x. You solve again for y. For the second one, I gave you domain to 5. If you do the derivative, it's minus 2 monotonic. Inverse is a function. You replace x by y and y by x. You solve again for y. This is the inverse function. Now, I want the domain of this one. We said if x is domain for f, y is the range. Now, for f inverse, the y will be the domain. So that's why I do f of 2 and f of 5. If you replace here by f of 2, you're going to get 3. Here at 2, it's a close. I have put a close not to get a mistake. And f of 5, it was here open, so it's f of minus 3 open. So for f of x, x was 2, 5. Its domain was minus 3, 3. For the inverse function, vice versa. This will be the domain, and this will be what? The range. Okay? You took it last year. Here I want to find the inverse. If you do the derivative monotonic, f of 0, f of 3, so minus 2.5, minus 14, both close. So the domain of the inverse function is from minus 14 till minus 2.5, and the range is that of x. Now we replace x by y and y by x. We do cross multiply. We put y on one side and put y in factor. You're going to get the inverse function. Here it's an equation of second degree. I want it from 0 till 1. As you can see, from 0 till 1, it is positive. So inverse is a function. So f of 0 is minus 1. F of 1 is 2. Here open, f of 0 close. So what do? We replace x by y and y by x. We take everything to the first side. Here in this equation of second degree, a is 1. B prime, I'm going to do delta prime, is 1 instead of being 2, and c prime minus 1 minus x. So I have delta b prime square, which is 1, minus ac, plus 1 plus x. So it's 2 plus x. So I have 2 inverse, either it's minus or plus. But here, as you can see, y is between 0 and 1. So I want y, this is y, because here x will be y and y that we have it here, which is minus